This problem is complicated only in figuring out what your initial and final values are. There is a roller coaster that is traveling in a sinusoidal wave, and we have a given radius of 15 meters. However, the mass of the roller coaster is in an arc type distance. So what we need to use is the value from the book to find out where r bar is. And once you find that equation, you can plug in the value you have of r equals 15 and get that r bar is 13.5. Once you have that, if you define that your datum is here, then you get 1 r bar and 2 r bar to this final value. Then our h simply becomes h equals 2 r bar. And that is really the only complicated part. Other than that, we have an initial velocity. A lot of the problems we've been working so far have either the initial or final velocity equal to 0. So just be sure you include both of those velocities. So for equation, we have the change in potential energy plus the change in kinetic energy equals to 0. And 1/2 mv squared is v2 squared minus v1 squared plus mg2r bar. That is equal to 0. The mass cancels out, so we don't even have to know how much the roller coaster weighs. And if you solve for v2, you get that it is the square root of v1 squared minus 2g times 2r bar. And when you plug in the value of 13.5 here, gravity, and the initial value of the velocity converted to meters per second, be sure you to do the conversion here. We can plug in those values to get 90 times 1,000 over 3,600. And all of that is going to be squared. Minus 4 times 9.81 times 13.50, and all of that will equal that the velocity at that second position is 9.75 meters per second. So just be sure that you know how to calculate the center of mass, because that is how you calculate the total change in potential energy.